Hi, this is Garrett Spencer and Zach Darnell's project, and I'm going to show you how to set up the Raspberry Pi data logger project. Alright, so here we need an LCD screen, and this LCD screen, you're going to be able to log GPS data right off of it. You can log other things too, but if you cannot get an OBD2 to work on your car, you can just log GPS. And GPS, all you need to do, you just need to buy this GPS module right here, and it has a USB plug-in which plugs into the Raspberry Pi right here. So the Raspberry Pi, as you can see, is I have bolted onto the back of the LCD screen. And then all you do is just plug that into one of the slots right there. Alright, so now your GPS is hooked up, and it's really important to make sure that the GPS can get a good signal. So you can either put it on your dash or you can put it on the roof of your car. Either one will work fine as long as it's getting a signal. Some people have just been able to put it in their console and still get a signal, but it really just depends on how it gets the signal. So that's the first thing that you hook up is the GPS, and as you can see right here is the USB plug-in for the keyboard. You'll need a keyboard to operate the screen, and you can get just a pretty cheap, simple keyboard like this Logitech one right here. It makes it a lot simpler if you have a touchpad to where you can move the mouse on the screen, so that definitely makes your life easier. So using that keyboard plugged in, and the LCD screen comes with this cable right here, and what you will do is you will just plug it in right into the Raspberry Pi, as you can see right here, and then right here into the screen so that you can actually get a display from your screen. So now you have the screen hooked up to the Raspberry Pi so you can read the data off of your screen, and then a USB cable right here that connects to the your power source, and this can just be connected into the car charger in your car if you have one, and that makes it a lot easier. So and sometimes you will see a flash lightning bolt up here at the top in the corner, and sometimes that just means it's not getting enough voltage, but it may be fine. Sometimes it's hard to get rid of that flashing bolt, but it really doesn't harm anything. So really you just hook this power source up right here. And then your screen should come on. I had some calibration issues with my screen, so it gives me weird lines, so it needs to be recalibrated. Alright, so theoretically once you plug the power in, your screen should pop up, and even though the Raspberry Pi is attached to the back of the screen, you can still load all of your code onto the Raspberry Pi, and all the code is in a document, and the code was gathered from document files uploaded by Professor McAlpin. So you just load those data files onto the Raspberry Pi and plug it in, and once you run the code, you should be able to get your GPS data, and then you can essentially tell where you are at any given time, and you can match up the speed of your car if you do have the OBD2 with the distance that the GPS logs. So there's lots of different channels you can add to this one, and this one was just done with GPS. So so that's pretty much the basics, and that's really all you need. Just the screen, the Raspberry Pi, and a keyboard, and the power source, and then you should be good to go. Alright, thanks for watching.
Hello, this is Zach Darnell, and I'm here talking about the data that was collected using the data logger. So, there were, at the drag strip, I did 2 separate runs, and here are the times are listed at the top left of the screen. Each run is listed and the time it took to do the run. So the first run that I ran, which actually the second run that I had, but the first run I collected data on, the time was 10.32 seconds, and the second run the time was 10.95 seconds. So I have graphs of each run and the velocity and acceleration each graph of each run, and on each run you can see the blue graphs are the acceleration graphs, and you can see where they peak and then drop off, and those values are the values for acceleration, and at the points where it starts dropping off, those are the points at which I shifted. My car is a manual transmission, so that can be used to tell the shift points of each run, and you can see the velocity increasing, and you can even see in the velocity graphs where they increase, where they decrease and flatten out more where the shift points are. So you can see that in each run, and just looking at those you can tell that it looks like the shift point was later on the first run than the second run. But looking at the graphing the acceleration both on the same graph, you can see that the run 1 is the orange graph, the run 2 is the blue graph. You can see that the acceleration in first gear was a lot longer and went up to a lot higher of a point than on the run 1 than run 2. So it shifted later on that point. And the time between that shift and the second shift was about the same, between shifting from second to third gear was about the same between the two, but the acceleration was higher again and the shift point was later. And then shifting to third gear at this later point, you can tell the acceleration is a lot lower than it was in first gear, and the acceleration is about the same and shifted about the same time. And then you can tell where the acceleration drops off after the finish line's been crossed. So you can, if you look here at the velocity graphs of the same data, you can see where the velocity started out a little bit lower on run 1, but at the point where I shifted on the second run, the first run went up to a higher point and the velocity stayed higher basically all the way to the finish line and finished 0.63 seconds faster in that run than on the previous run. There were several other things. The accelerometers on the SenseHat that was used in the Raspberry Pi, the data was very jumpy. It was hard to get a good read on that data, so that data wasn't used. The acceleration data that was used in this was actually used by calculating the change in the velocity GPS data. So that was what was used, and to get these accelerations and see the different shift points and analyze that. So just looking at this, I would say next time I go to the drag strip, I need to probably wait even longer, or at least wait as long as I did in the first run to shift to first gear, and then wait longer in second and possibly third gears to get the most out and rev up the engine and get it to the higher point, get some more acceleration out of it. So the later I shift, the more I get into the power band, the faster my time would be. So analyzing that, I can see the major difference between these two runs and improve future performances at this. All right, that was our data logger project. I hope this was interesting to you. I really enjoyed making this and wish you all the best.